In this video, we will be reviewing the concepts we have covered thus far in Chapter 6, Radical Functions and Rational Exponents. Those concepts include simplifying radicals, adding, subtracting, multiplying, and dividing radicals, and rationalizing the denominator. For numbers 1 through 4, we need to find the real number root. For number 1, we have the square root of negative 1.69. Taking the square root, we actually get 1.3i. However, since we got an I as part of our solution, there are no real roots. For number 2, we are now taking the cubed root. When you take the cubed root of a negative number, your solution will also be negative. 125 is 5 to the third power, so the cubed root is 5. And 343 is 7 to the third power, so the cubed root will be 7. And that is your final answer. Moving to number 3, this is a little more involved. We notice the index is the same, so we can write them underneath the same radical, giving us the cubed root of 108 times x to the 26th power over 2 times x. Simplifying, we will get the cubed root of 54 x to the 25th. Now 54 is 27 times 2. We know the cubed root of 27, that's 3. 2 will have to stay under the radical. Taking 25 and dividing by 3, we will get 8. So we have x to the 8th with 1 remaining, so we have the cubed root of 2x. Moving to number 4, this one's very similar to number 3, except our roots are different. They are not cubed roots anymore, now they're square roots. So I'm actually going to skip right over here to simplifying this. We threw everything under the same radical and simplified to get the square root of 54 x to the 25th. Now 54 is divisible by 9. It is 9 times 6. We can take the square root of 9 to give us 3. 25 divided by 2 will give us 12 with a remainder of 1. So we end up with 3x to the 12th times 6x. Final answer. For number 5, we need to multiply. So foiling out, we get 7 times 1, which will give us 7. 7 times square root of 10 to give us 7 square roots of 10. Square root of 10 times 1, which will give us the square root of 10. And the square root of 10 times the square root of 10, which is the square root of 100, which we can simplify to give us 10. Combining like terms, we get 17 plus 8 square roots of 10. Repeating the same process for number 6. The square root of 10 times the square root of 10 is the square root of 100, or 10. Square root of 10 times negative square root of 5 is negative square root of 50. Square root of 5 times square root of 10 is positive square root of 50. And the square root of 5 times the negative square root of 5 is negative square root of 25, or 5. The negative square root of 50 and positive square root of 50 cancel each other out, leaving us with 10 minus 5, which we simplify to get 5. Now for number 7, there are actually 2 methods we can use to simplify. We have 9x to the 4th, y to the 8th, all to the 1/2 power. One method we can use is properties of exponents. According to the properties of exponents, when you raise a power to a new power, you multiply the exponents together. So we will have 9 to the 1/2 power times x to the 4th times 1/2 times y to the 8th, again times 1/2. 9 to the 1/2 power means something squared is going to give me 9. That number happens to be 3. For x, we have 4 times 1 to give us 4. Divided by 2 will give us x squared. for my y's, 8 times 1 is 8, divided by 2 is going to give us 4. So we have 3x squared y to the 4th. Like I said though, there's another method. The other method is converting to radicals. Since this entire expression is raised to the 1/2 power, we can write it as the square root of 9x to the 4th y to the 8th. The square root of 9 is 3. When taking the square root of exponents, you divide the exponent by the index for both of them. So 4 divided by 2 will give us 2, and 8 divided by 2 will give us 4. Same answer, different method. For number 8, we need to rewrite the following exponential expression in radical form. Be very careful here. This 4 is not being raised to the 5/8 power, just m. Since 4 is not being raised to the exponent, it is not affected by rewriting in radical form. So when we rewrite this, leave the 4 alone. Your denominator becomes your index, giving you the root of m to the 5th. Your final answer is 4 times the 8th root of m to the 5th power. For number 9, we need to find the simplest form of the expression. We have the cubed root of 36 minus the cubed root of 9 minus the square root of 3. We cannot combine these two terms because while they may have the same index, the radicands are different, so they are not like terms. Same with this last term here. Its index is different from the first two, so it is also not a like term. So first we must try to simplify to get them to be like terms. If we factor 36, that will give us 6 times 6, which you can continue to factor to get 3 times 2 if you wish. Either way, we do not have the 3 of a group needed in order to pull something to the front of my radical. So the cubed root of 36 will remain the cubed root of 36. Repeat the simplification process for the cubed root of 9. We would try to factor to get 3 and 3, but again, we do not have 3 of a kind to bring to the front, so we would leave it alone as the cubed root of 9. The square root of 3 also cannot be simplified, leaving you just with the square root of 3. So your question was already in simplest form. For number 10, we must simplify, showing all work. Again, there are 2 methods. The first, using exponents. When you multiply like bases together, we add the exponents. That will give us 15 to the 1/2 plus 1/2, which will give us 15 to the first, simplifying to just 15. The second method is by using radicals. We can convert this to the square root of 15 times the square root of 15, which will give us the square root of 225, which simplifies to give us, again, 15. Either way, same answer. For number 11, we need to rationalize the denominator. We're given 5 divided by 1 plus the square root of 2. Now, to rationalize the denominator, we need to think back to what we did in Chapter 4 when we were talking about imaginary numbers. We have rationalized a denominator before. Think back. 2 over 1 plus 2i. In order to get rid of this I, we had to multiply by the conjugate, which was 1 minus 2i. Did the same thing in the numerator. Keep this in mind now as we go through and do number 11. Again, using conjugates, we're going to multiply by 1 minus the square root of 2. Do the same thing in the numerator as you do in the denominator. For the numerator, it's going to be simple distribution, and the denominator will end up foiling. In the numerator, we'll get 5 minus 5 square root of 2. And in the denominator, we get 1 times 1 to give us 1, 1 times negative square root of 2 for negative square root of 2. Positive square root of 2 times 1 for positive square root of 2. And the square root of 2 times the negative square root of 2 will give us the negative square root of 4, which is 2. Now the really cool thing, again, about multiplying conjugates together is the funky stuff, your roots, your radicals, and your imaginary numbers cancel each other out. So this negative square root of 2 and this positive square root of 2 will cancel, leaving you only with 1 minus 2, which is negative 1. In the numerator, though, we still have 5 minus 5 times the square root of 2. Now, since we're dividing by a negative number, we need to go through and change my signs. So my final answer will be negative 5 plus 5 square root of 2. For number 12, we again need to rationalize the denominator. First, notice that the indexes are the same, so it's actually possible to write these underneath the same radical. We will get 2 times the cubed root of 9b squared all over 3a cubed bc. Now we can actually simplify inside of our radical. Keep that 2 out front, and then we'll have the cubed root of 3b, because 9 divided by 3 will leave us with 3. B squared divided by b will leave us with b, over a cubed and c. So now we have to rationalize the denominator. To do so, let's multiply by the stuff that's missing in order to complete these cubes. A is already cubed, so it's good to go. However, C, we need 3 of them, we only have 1. So we need to multiply by the cubed root of c squared, both in the denominator and the numerator. That way it stays equivalent. Multiplying together, the 2 stays out front, and we'll get the cubed root of 3bc squared all over, well, now a is cubed, c is now cubed, so we can write this as AC. Just to make it look a little nicer, we'll put 2 back in our numerator. We'll have the cubed root of 3bc squared all over AC. Final answer. Make sure you study, review these again if you need to, and good luck on your test tomorrow.